All right, so let's put this into action a little bit. So coming back to this Desmos screen here, so you can see the red line is our original parent function, the square root of x, right? The most basic version there. And then you can see the blue line. And let's just try to name these different transformations, okay? So first of all, let's start with the adding and subtracting. So I'm adding 3 on the outside, so that's going to move it up 3, right? So we moved it up 3, and so now instead of our kind of anchor point here being at the origin, now it's going to be up 3. We also subtracted 1 on the inside, so remember that's going to move it left or right, and usually subtracting 1 we would think move to the left, but remember everything inside is backwards, so it's actually going to move it to the right 1. So that's how we get to here, 1 comma 3. Okay, and so we went up 3 and right 1. Okay, based on these two. Then we have this this -2 out here. Okay, so the negative on the outside makes it flip upside down, right? So it's going to reflect about the x-axis, and so that's why it's upside down here. So it's going down as we go, and then we also multiply by 2. So remember, outside, if we multiply by 2, it's going to be a vertical stretch, and so it's stretched as well. And so you can see it's a little steeper than the original red line was, right? Instead of 1, 1, here when we get to 1 unit, it actually moves, it's upside down, so it's going to move down 2 units. So the slope is a little bit steeper, right, at every corresponding point. Okay, so that's what happened here with this blue line. Now with the green line, we subtracted 1, so that's going to move it down 1 on the outside, right? We subtracted 1 on the outside, so it's going to move it down 1. We also added 2 on the inside, so it's going to move it to the left 2. Okay, so you can see that's how we end up here with the green line. So we moved it down 1, left 2. Then we have a -3 multiplied on the inside. So our multiplied is a shift, or is a stretch or compression. So if we multiply by 3, a number bigger than 1, it's going to be a horizontal compression. So it's actually going to squeeze it in from left to right, okay, which kind of makes it look like it's going to be taller, but it's technically a horizontal compression. And then we also have a -3 inside here on the inside, and so that's going to make it be a reflection across the y-axis. So it's going to reflect from left to right, right? So instead of this going out to the right, as you saw with the parent function, now it's going to be starting at that anchor point and going out to the left. Okay. All right. So you can see it kind of all coming together. You can have all those different transformations happen at the same time. And that's how you identify them, is ask yourself, what operation is it? Are you adding and subtracting, or are you multiplying, or are you changing the sign, right? And also ask yourself, where is it? Is it inside or is it outside? Okay. And so remember, adding and subtracting is a shift, up, down, left, right. Outside is vertical, inside is horizontal. If you're changing the sign, it's a reflection. If it's outside, it's vertical, so it's across the x-axis, up and down. If it's inside, it's horizontal, left to right across the y-axis. If you do it both places, remember, it's about the origin. Okay, so if I were to put a negative outside here, then it would reflect both ways, and it would essentially be a reflection across the origin. Okay, and then when you multiply, remember, multiplying outside is a vertical stretch or compression. Bigger than 1 means stretch, less than 1 means compression. If you're multiplying inside, it's a horizontal stretch or compression, but it's backwards, whereas if you multiply by a number bigger than 1, it's going to be a horizontal compression. If you multiply by a number that's less than 1, it's going to be a horizontal stretch. All right, let me know if you have any questions, and we'll practice this in class.